Hello everyone, I'm Sonny Collado, and today we are going to talk about the discussion 2. It means the chapter 2 of our topic. To start, I'm gonna talk about the elements. What is a element? An element is a substance that cannot be broken down in a simpler form, because it's already in its simplest form. So that could be contradictory. So what happens? The element has atoms. These atoms also cannot be broken down in simplest form. That's why it happens. So to clarify well, what is an atom? An atom is gonna be the smallest part of an element, and this one cannot be broken down also. So, but what has an atom? An atom has three things: proton, electron, and neutron. The electron is the one that has the negative charge. The proton is the one that has the positive charge. And the neutron is the one that has the neutral charge. That means the neutron doesn't have neither the positive or negative charge. So these are one of the explanations and the basics of this chapter 2. What did I like from this chapter? Well, the, the experiment of cathode, cathode rays. This one is basically a experiment based on images. It's not like based on images. It's like it has two electron guns that in a certain way can make an image of the particles inside of the experiment. So was pretty good to see it in class and to be a part of it, and I will see more of it. I will see experiment of it, and yes. So after my finish of after my ending, now we're gonna have our classmates or my partners that are going to disclose more these topics and the chapter two. Thank you so much.
Hi everyone, my name is Valeria Hilsa. I'm gonna talk about what I learned from chapter 2 and some challenges that I had. From this chapter, I learned that isotopes are atoms of the same element that have the same number of protons but they have different number of neutrons. Because they have the same number of protons, they're still considered the same element and have the same chemical properties. However, the different number of neutrons change their mass. For example, esto magia edición. Ay, fue puta. Mm, Ay, me importa un culo. Yeah. Okay. For example, hydrogen has three different isotopes: protium, deuterium, and tritium. They are all hydrogen, but because each one has one proton that is shown as an orange ball, but they have different number of neutrons that is shown as a green ball. Ah, corta esa mierda. I also learned that atomic mass shown on the periodic table is not the mass of one isotope. Instead, it's the weighted average of all natural occurring isotopes of that element. The challenges that I have from this chapter is specifically this topic, and that's why I want to talk about it. Since the beginning of the class, once we touched this topic, I was completely new into it because I didn't remember this from high school, and I had some difficulties in the problems, but practicing from Alex and the professor's problems helped me to understand it better. Overall, understanding isotopes helped me see how atoms of the same element can have different masses while still having the same chemical reactions.
Hello, my name is Nathaniel Masentapon, and I will be covering Rutherford School's oil experiment for Chapter 2. Now, as we all know, atoms are consisting of protons, neutrons, and electrons. And now, before Rutherford conducted his gold foil experiment, it was assumed that all particles were uniformly based around an atom, and there was no strict structure to it. And with Rutherford, he used a particle emitter and used the particles to pass through gold foil to see what would be detected. And through it, we can see that certain particles are able to pass through, certain smaller particles that are smaller than the gold atoms are able to pass through, with certain ones bouncing off where there's heavier and deflecting, where there's heavier mass. With this, it is concluded that most of the atom is empty space, and that a small, dense nucleus is what contains most of the mass of an atom. Now, with this, they developed the concept of the nucleus, a charged nucleus of protons surrounded by electrons, with neutrons that are also present within the nucleus, but it allows the charges to balance. And this leads into isotopes where the nucleuses can have varying levels of neutrons. So, in order to answer this question, it proves that the mass of an atom is always going to be concentrated within its nucleus.
I learned a few things studying chapter 2. One thing I did learn was the classification of the periodic table. In this chapter studying, I learned that the periodic table is organized and the elements are organized based on their atomic number, and they're all grouped together with other elements with the same chemical properties. I also learned about groups, periods, and how the position of an element can help predict the behavior of that element. I would say the most difficult part about this chapter for me was just remembering the different groups and understanding why the same elements in the groups have similar properties. At first it was confusing because there were a lot of different elements and different patterns, but studying, and I challenged myself by doing practice questions and studying the periodic table. So those are ways I kind of overcame that challenge. But like I said, this wasn't too difficult of a topic in this chapter. And yeah.